In 2.2D, I'm going to show you how to use Table A or your calculator to find the percentile of a value from any normal distribution. So in the previous video, we actually were exactly 1, 2, or 3 standard deviations away. We're now going to look at examples where we may not be exactly those 3 standard deviations, so we're going to need to use some other devices to get the exact answer. So let's review this really quickly. The normal distribution, when we do standardize the data, gives us a mean of 0 and a standard deviation of 1. Remember, we used the z-score for that, so we took a piece of data minus the mean, if it's the population, over the standard deviation. Remember, if it was a sample, by the way, it would be our piece of data minus the sample mean over the standard deviation of the sample. So this notation means the same thing. This is for population, and that's for a sample. Now, the standard normal table, it's a table that you are given on the actual AP exam. It's part of your formula sheet, and it's also in the back of your note packet. So if you turn and look at the back of it, you should find it. What it is, it's a table of areas under the normal curve. The table entry for each z is the area under the curve to the left of the z. So it's important if you use the table, you read it properly. For example, when you go to the table, and let's say this is a 0 z-score, what if you want a 1.0 z-score and you want the area? When you look it up on the table, it's going to give you the area to the left of that z-score. So you have to be creative if you have to find areas to the right of the z-scores if you use the table. So if you haven't yet, again, go to the back of the note packet, or if it's in the notes itself, look and refer to the Table A, which will be supplied to you on the exam. Here's the first question. Suppose you wanted to find the proportion of observations in a normal distribution that were more than 1.53 standard deviations above the mean. So we're talking a positive. So I'm going to do a quick sketch of that. And it could look something like this. So quick normal shape, I put the mean at 0. This would standard deviation 1, 2, and 3. So 1.53 is there. And again, we are looking at above the mean in this case. So we are looking at this shaded region. How you would go about doing that is on the table, notice it says the z's. So these are the z-scores to the 1s in the 10th position. This is in the 100th position. So what I'm first going to look up on the table is the 1 and the 5 in this section right over here. So 1, 5 is right there. Now I look at the 3 over here on this position, and we find the 3, and then we just go ahead to where they match up. And what that shows me is the area is 0.937. That is this particular area over here is the answer. I need the red sector, so easy enough. All I need to do for that is to take the 0.937 and subtract that from 1. So again, we're just being thoughtful on the math that we have to do to back into it. And when we do that, we're going to get 0.063, which a decimal answer is completely acceptable, or if you wanted to write it as a percent, you could convert it to a percentage. And again, if you're ever using the table and you forget what these numbers represent, just look at the description and diagram up here. This is where they're telling you it's giving you the area to the left of your z-score. All right, let's do another one with the table, and then I'll show you how to use your calculator instead. Find the proportion of observations from the standard normal distribution that are between negative 0.58 and 1.79. Again, I'm going to do a quick sketch of what that would look like first. So I'm just going to piggyback off of this particular image up here. Again, the mean of 0 for the z-score is right in the middle. I want to go to 1.79 and all the way down to negative 0.58. So the area under the curve is going to be this region. To use the table, we could do 2 different approaches. First thing we can do on the table is we could find the z-score of 1.79, and it's going to give us this entire blue region. Let's go ahead and do that. So here's 1.7. The 9 is right over here, and if we follow that through, we're going to land, it looks like, at 0.9633. So this is 0.9633 is the area from this line all the way back. Now what I need to do is to try to find the area from this z-score all the way back. If I can find that particular area, then what I could do is take my value at 0.9633 and subtract this value from it, which will leave us with the red region. Now there's also a second table that they have. They do have negative z-scores supplied to you. So if you also look in the back of the note packet, you're going to find this z-score table. And the negative one, if we do negative 0.5 and we find the 0.8, we're going to see that the area here in the green is 0.2810. So if we go ahead and subtract these two values, we're going to end up getting 0.682. Again, this is an acceptable way to write it, or 68.2%. Make sure you show the AP board the actual calculation. It may seem very basic to show them that you can subtract two numbers, but a lot of the times they're going to say if the work is not shown, you may not get full credit, so be very careful. Now let me show you how to actually use the calculator. Now to do this on the calculator, you're going to want to find the list where all the probability stuff is, and you're going to find it right here. This word distribution, which is on the above the var keys. So to get to distributions, hit second vars, or to get second to the distribution. To do that, you're going to get to this screen right here. We are looking for normal CDF. Notice the first option is normal PDF. PDF stands for point, CDF stands for cumulative region. We will never ever use the one that says point. So completely ignore that. We never use that. If we do normal, it's always normal CDF. Now the parameters we want to type in on the newer operating system is going to prompt you for this. If you have the older operating system, you have to be careful. What the older operating system will do is once you hit normal CDF, it's just going to show this screen and you have to type in the 4 parameters. If you do not have this showing up, please come and see me. I want to update your operating system. For normal CDF, it's not hard to remember what you type in, but we start using this list more later in the book, and you don't want to have to remember. You want them to prompt you. So here's what they're going to prompt you for, is the lower bound, the upper bound, the mean, and the standard deviation. So remember on our curve, they wanted to find this region in between negative 0.58 and positive 1.79. So all you have to do is literally type in the range. Now, the mean of a normal curve is 0, standard deviation is 1. You type that in and you hit enter, and here's the actual answer, which is the exact same answer that we got before. You are more than welcomed to use the calculator method versus the table A method on the actual AP exam. They do not care. Now, I will tell you, if you use the calculator method, you must write down enough information. What you must write down is this statement right here. And in addition to that, you have to identify the mean and standard deviation and the type of distribution. So you write this down, and then you must say it's a normal distribution. You must say that the mean is 0 and the standard deviation is 1. If you are missing this side information, but you have this written down, they will not give you full credit. They call this calculator speak. Again, you must say the type of distribution we have, so it's normal, and you must say the mean and standard deviation. Folks, they basically want you to list the SOCs for it. Think about it. Shape, center, and spread. You always have to list shape, center, and spread, so be very cautious if you use the calculator. I highly recommend you use the calculator because it's what I'm going to suggest you use for most of the analysis in this book. Let's look at this last slide, and I'm going to use the calculator speak for all of it. So starting with number 1, they want the z-score is less than 1.39. So let's do a quick sketch of that. So our visual on that is going to be this area under the curve. We know the answer is going to be a fairly large number and close to 1. Now, to type that in your calculator, I'm going to go to normal CDF. Then I'm going to type the lower bound and the upper bound. Now, this is a continuous curve, so the lower bound on this technically goes to negative infinity. Type in just a really big negative number. I always like to do just like negative 999, something like that. It doesn't really matter what this number is as long as it's a large enough negative number. And then our upper bound is 1.39, the mean is 0, standard deviation is 1. You would hit enter and get the actual answer on this. Now remember, for calculator speak, I need to list somewhere on there that it's a normal distribution, so I'm going to list normal. I'm going to say the mean is 0 and the standard deviation is sigma is 1. That'll cover me for calculator speak. And when I type that in my calculator, I'm going to get the answer of about 91.77%, which my gut tells me is reasonable. Okay, the next one. Let's find the probability or the area under the curve or the percent if the z-score is greater than negative 2.15. Doing a quick sketch of that, we're going to see that we want to have everything above negative 2.15, so it's going to be to this direction. Now, if you do use Table A, I do recommend using the negative z-score table. Again, I'm just going to use the normal CDF calculations, and to write that, just do normal CDF. Now the lower bound on this one is the negative 2.15. The upper bound this time goes to positive infinity over here. So I'm just going to put 999 or 1,000 or 10,000. Mean is 0, standard deviation is 1. Now to do my calculator speak on this one, what I'm going to do instead, and you would get credit for this, is I'm going to actually put an arrow do mean and do an arrow here, standard deviation. And then I will make sure again to say that it is a normal. So you do have to have that listed somewhere. I should get full credit for that. When we type this in the calculator, our answer is going to be about 98.4% or 0.984. Okay, our last one is an in-between statement, so let's make a sketch of this particular scenario here. It's a pretty rough sketch, but I get the idea that I need to find the area under the curve between this region. Again, the language for that is normal CDF. The lower bound and upper bound on here are straightforward, so I'm just going to type that with a mean of 0 and standard deviation of 1. So here's my calculator speak. Here's the supporting information about the shape, the center, and the spread of my distribution. Type that in the calculator and we're going to get our answer of 0.677. And that's how you do this learning objective.